and welcome back. Today our MLO is I can simplify rational exponential expressions by applying the properties of integral exponents to rational exponents. Today we're going to look at the product rule. And it kind of says what it does in the rule. It takes the product, meaning you multiply. So when multiplying two numbers with the same base, so in this example, A and A are the base, you add the exponent. So you see here that you have M and N, and it's being multiplied. You then add the exponents together. So, for example 1, first we see that all of these bases are x's, and it's being multiplied. So that means we can keep the same base, and we're going to add all the exponents. So 2/3 plus 4/3 plus 1/3. Okay, and that will give us x. When we add exponents together, when you add fractions together, the base has to be the same, which it is. So we keep the same base of 3, and then we add the numerators. So 2 plus 4 plus 1 is 7. So x to the 7/3 power. Example 2 says y to the 1/2 power plus times y to the 1/2 power. The same base are multiplying. Keep the same base. We add the exponents. So that's y to the first. 1/2 plus 1/2 is 1. And we typically just write that as y. You don't need to write to the first power. And just a reminder, if these videos are going too fast, pause it. Okay, we go fast for a reason, so we can get everything in one video. So pause it if you need to. Example 3. Everything here is being multiplied together. So I'm going to look for the stuff with the same base. So I see f and f. So I'm going to have a base of f, and I'm going to add 1/4 plus 5/4 for the exponent. I see a base of g. So g stays the base, and then I add the exponent. Well, here the exponent is 1 since nothing is written. So 1 plus 2/3. So that gives us f to the 4 will be our denominator, 6 is the numerator, and G, this will end up being 5/3 power. So 1 can be changed into 3 plus 3, 3/3, which is 2/3, and that's how we get 5/3 for our exponent. 6/4 can be simplified though. So that will be f to the 3/2 power, g to the 5/3 power. That's your final answer. For example 4, we have these coefficients. There's a coefficient of 1 in front of the b. So I'm going to pull all those coefficients out here in front and multiply them together. Then I look for common bases. I see c and a c. So I'm going to have a multiply by c, and I add the exponents. 2 this plus 3 this. And then I have d and d, so multiply by d. We add the exponents, so 1/2 plus 1/4. So the coefficient out front, 3 times 2 times 4 times 1 is 24. C to the 5/5 and d raised to the 3/4 power. The last thing I want to do here is change this 5/5 to 1, because 5/5 is just 1. So our final answer is 24c to the first power, and we don't usually write that 1. d to the 3/4 power. Here's our final answer. Example 5. We have 3x to the 4/5 times 2x to the 2/5. Now everything's being multiplied here, so I can apply this property. So the 3 and 2 coefficients I'm going to bring out front. X is our common base, so I'm going to rewrite x, and then you add these exponents. So 4/5 plus 2/5. So I have 6, which comes from the 3 times 2. X raised to the 6/5 power. And again, I get that from taking 4 plus 2, which is 6, and then we keep the denominator of 5. And that is our final answer. Lastly on this page, number 6, same idea. We have these coefficients 2 times 9 times 3. So first I'm going to pull those out. Now I notice here I have a as a base, and that's raised to the 1st power, and a as another base raised to the 2nd power. So times a to the 1 plus 2 power, and then I have this b to the 4th, and it's the only term, so I'll leave it as b to the 4th. 2 times 9 times 3 is 54. A to the 3rd power, b to the 4th power, and that is our final answer. The last rule we're going to look at today is the power rule. So this means when you have a power, this m is a power, the exponent, raised to another power, you multiply them. So here, x raised to the x to the 6th power, that whole thing raised to the 1/3 power, you take 6 times 1/3, so that's x to the 6/3 power, or x squared. Final answer. Here we have 1/2, and the 1/2 needs to be raised to both the 25 and the x to the 4th. So we have 25 to the 1/2 power, x to the 4 times 1/2 power. Multiply the power rule there. 25 to the 1/2 power is 5. For x to the 2nd power, when you take 4 times 1/2, you get 2. And that's simplified, and that's our final answer. Example 3. Y to the 8 raised to the 1/4 power. So we have y to the 8 times 1/4, which is y squared. Done. Whoops. Let me rewrite that. Y squared. Same idea for this one as we did in example 2. The 1/3 power needs to be raised to the 27, and also to the a to the 9th power. And since it's a power raised to a power, we multiply those exponents. 27 to the 1/3 power is 3. A is our base, and then 9 times 1/3 is 3. And that is our final answer. Last two examples. Example 5. Look at this. C to the 12th power to the 1/4 power to the 1/3 power. Same idea. We're just going to multiply all of those exponents together. This is just the power rule twice in a row. So C stays our base. 12 times 1/4 times 3 is 1. And we don't typically write the 1, so C is our final answer. Lastly, we have lots of stuff going on here. First of all, I want to point out that the negative is out front. So I'm just going to rewrite the negative here, and it'll just kind of go along with the problem right now. We have this power of 3 that needs to go with the 4. So 4 to the 3rd power. The 3 also needs to go to the x. So that would be 4 times 3 as its exponent. All of this is being multiplied together. The 2 out here will go to the coefficient of 2, so 2 squared. The 2 will also go to the x, so that exponent is 5 times 2. All right, so change the colors. Negative is just going to stay with the problem. 4 times 3 is 64. Our exponent for the x, 4 times 3 is 12. 2 squared is 4, and x to the 10th power. Now I notice right away, this doesn't really look that pretty. I might have a number right here, negative 64, and a number right here. So those coefficients I'm going to multiply together and pull out front. Negative 64 times 4 is negative 256. That's our coefficient out front. And then we have x as a base and x as a base, and it's being multiplied together. I'm going to have x as the base again, and I add the exponents 12 plus 10. So finally, negative 256 x to the 22nd power is our final answer.